This is going to be an OTF primary conversation. We don't actually have a team. The team is ourselves that we're going to interview this week. Excitingly, we're going to talk about what OTF is doing, what we've been developing, how the company's been moving, what our vision is. We have Garrett on the stage. Garrett is the CTO at OpenTensor. We're also going to be joined with the lead of Nucleus on the call. I'm going to actually pull up Formalize right now. So he's head of our blockchain team, and go through the steps that we're taking right now to position Bittensor, the network, OpenTensor, and the community to prepare for a revolution like dynamic tau. We think that there are some major things that we need to do before the network is ready. We want to increase transparency. We want to increase the performance of the subnets. We want to expand the toolkit we have to fight things like weight copying. We've talked about that on a previous call. And we have a bunch of new things that we're going to talk about on this call. It's just a short roadmap. It's not the full roadmap for OpenTensor over the next few months. It's just simply a quarterly roadmap for us where we're going. Hey, Formalize, you're getting some feedback here if you can mute yourself. And Garrett's going to take us through the call, a slide deck we have. He'll share his screen in a moment. And then at the end of the call, we'll have a normal sort of community chat with people that want to come up on stage and hear about what we're doing, ask questions about what we are presenting here. Yeah, so without further ado, let's jump into it. So Garrett, maybe you can introduce yourself a little bit formally.
Yeah, hey guys. I know that I've talked with some of you guys throughout the community. Some of you may know me. I'm Garrett, the CTO of OpenTensor here. And I'm really excited to share with you guys some changes that we have internally in the company to really propel Bittensor forward in some pretty big ways. So I'd like to jump in first by talking about our focus for Q3. And our focus is really on improving stability, reliability, and transparency throughout the Bittensor ecosystem. That includes our interactions with the community, that includes the stability of the chain, that includes the BT CLI, and really we want to make sure throughout this whole upcoming quarter that these three things ring true as our main priorities as we develop new features. And we've taken a lot of feedback recently, and we are acting on it. And we are improving the way we do upgrades, the way we really improve this platform, this ecosystem, so that we can all be more productive and actually innovate on this platform. So without further ado, I'd like to announce formally that we have a new release cadence internally. And I wanted to share that with you guys to provide some transparency. As you know, I stated just in the slide before, that transparency is a huge goal of ours, and so that starts now. And so to be transparent, we are operating internally on a 2-week cycle for releases. And we are releasing testnet upgrades at least 1 week prior to all mainnet upgrades. So what that means is that when we update testnet, we provide notice to the community with documentation, with Bittensor versions if necessary, and we provide information for the community to try out new features. And these features will come the following week afterwards on the mainnet. So this gives the community advanced notice of what is coming and gives them an opportunity to try things out. And we also have our internal clone nets. So in an effort to improve the stability of both the mainnet and the testnet, we actually will be doing and have been doing clone upgrades internally. And these are direct copies of testnet and mainnet that we use internally to guarantee to the best of our abilities that features that we develop are stable and that people can trust that testnet and mainnet are fully functional. So what does this release cadence look like? Well, in this simplified diagram here, this is kind of an idea of what our cadence looks like internally. So we operate off these 2-week cycles, and a cycle is essentially ended by a release to testnet. And then we have the Finny deploy on mainnet the week after that. So we have a week of time where the community can try out testnet and provide feedback, and we can address those concerns. So we want to do this so that we can make sure that development is consistent and that we can deliver features that is needed by the ecosystem to improve Bittensor, while also making sure that the community is well aware of what we're doing and that they have plenty of time to prepare in advance for any changes that are coming their way. So that's a brief look at what our internal cycles are looking like. And so to kind of go through this with more depth and more clarity, I want to talk about a little bit about what we've been doing up to this point. So we've implemented this cycle, and in this cycle, we've released a couple of new things. I've been working on a couple of new things. And one of those things is commit reveal. And this is something that I know that we've experienced some issues with this. This is part of this transparency that we want to be open with you guys about. Is when we released this, we heard that some folks were experiencing issues, and we took that very seriously, and we are currently in the process of releasing a patch for one of the issues that we experienced on the main chain. We released a patch recently on the BT CLI as related to commit reveal. And we appreciate all the feedback that we are getting during this process. And we are continuously improving what we're doing here. So we have commit reveal that we released this last sprint. We also have liquid alpha, which is coming to testnet very soon. And we are really excited about both of these things. So I'm going to hand the mic off to Jake to talk a little bit more about the commit reveal stuff and liquid alpha.
Adding some color though, just to the previous couple slides here that we were looking at. A little while ago, we had a chain go down. And this was because there wasn't sufficient testing on the specific release before it went out. And so going back one more slide there, I want to talk a little bit about all the ways that we prevent any issues from actually hitting mainnet from OpenTensor side. So primarily we test on a DevNet. Before we get to testnet, we're obviously going to test the DevNet with end-to-end tests. Then when we do a testnet deploy, we actually create a full clone of the entire state of testnet before pushing the release. And then finally, we wait a whole week where we can test, and hopefully the community can help us out on this stage, specifically the Church of Rao and developers that are working with our technology. We want this transparency so that you guys can help us test these things before they come to mainnet. And then for the mainnet release, we do the same thing. We do a full clone. It's 20 validators that we have to spin up. We do a chain upgrade on the mock network, the copied network, and then only after that upgrade is for sure gone through, and it's totally isolated upgrade, then we put it to mainnet. So if there is an issue that can arise on the upgrade, we will catch it at least in 2 places, probably 3, with end-to-end tests and clones. And this is all part of our push to really improve the foundation of Bittensor behind the scenes to make sure there's just never an issue that comes onto main. So I mean, it's a work in progress. We're obviously not totally there yet. Sometimes issues with the CLI get passed through. This was happened just yesterday, and today we found some issues, but we really are improving this release cycle. But let's go forward. So let's talk about commit reveal and liquid alpha. But I want to paint a picture here about where we are on our major push. Like, we're not releasing a roadmap here, but we are on the road towards something like DTAO and STAO as a precursor to DTAO. But before we can have that amount of scale and innovation that's happening on Bittensor, where we have hundreds of thousands of subnets, we need to solve individual issues that are arising in those subnets and make sure that they're stable. There's transparency. There's the community of subnet developers have the tools to combat things like weight copying, to increase the level of consensus in the networks. And then finally, at the end of the slide, we'll talk about how we're allowing for validators to collaborate and not need to validate on all of the many, tens and soon to be hundreds of subnets that are running on Bittensor. There's a variety of things that are going on behind the chain, behind the scenes here, that we're not going to talk about on this. We're just going to talk about features. But we have been pushing in large ways, upgrading Polkadot to improve the performance of the chain, to reduce chain bloat, to reduce the amount of data that goes on the chain, the speed at which blocks can go, the number of subnets we can have from an infrastructure perspective, with things like dynamic tempos and dynamic numbers of UIDs. We're just going to talk about features right now. And these are things that the community will experience, but there's a whole other iceberg of innovation going on underneath OpenTensor that we'll talk about maybe at another time. So let's chat about commit reveal. Weight copying. It's been the bane of our existence for some time. OpenTensor's perspective on you could think of them as like incentive breakdowns, is that we don't take sides. Our goal is to build tools for subnet owners to build incentive mechanisms and incentive landscapes that produce value. And people have different opinions. This is a bit of a polarizing topic. We built in commit reveal as a tool for subnet owners to combat weight copying if they want to on their subnets. And currently, this is out there live on main chain as of yesterday. So people can use, they can update their subnets so that there's a commit reveal strategy, specifically where validators will need to wait a certain number of blocks before they're actually able to reveal the weights that they've previously committed. And we did the analysis from our research team, and we released that analysis. And for a number of subnets, this can be very positive when it comes to forcing validators to actually participate in the running of the validator code rather than simply optimizing their weights. Roughly, and this is not the place to go into the deep technicals of how commit reveal happens, but I mentioned earlier, validators commit the weights that they're going to via a hash to the chain and then can reveal it later. It involves, when it comes to a subnet, you'll need to actually write your subnet code differently to use commit reveal, where you have a commit step and then a reveal step in the validators. So we imagine that in the near future, subnets will make this upgrade slowly but surely. It's not going to be everywhere, but it will be in most subnets, we hope. Pushing out weight copiers is a huge thing, but commit reveal is not the only way that we can do that. So let's move on to the next step. We're rolling out sort of a multi-stage approach to weight copying. It's been the major focus for the last 4 weeks at OpenTensor. Commit reveal is just the first stage. The second stage is actually punishing those that are out of consensus. Sorry, not those that are out of consensus, but those that are not actually attaining the consensus through validation. So we've turned that process into more of a speculative weight setting process. We call this liquid alpha. And it comes down to the way in which the validators are rewarded via the bonds matrix. People here are familiar with dividends. This is the major signal that validators are following. We're changing the way, this is an upgrade to the Yuma Consensus mechanism. So right now we're using non-liquid alpha bonds. And this means that the bonds accumulate at a consistent rate in miners. So a validator sets weights on a miner, and the rate at which the bonds are accumulated in that miner, which then determine their dividends in the calculation for Yuma Consensus, that is consistent in non-liquid alpha. We've changed that so that instead of it being fully consistent, the same alpha term per miner, that value can be changed and actually modulated by a subnet owner to create speculation, where there's an exponential curve such that if you're a validator and you set weights in such a way on miners that are not yet in consensus, but will eventually reach consensus, you can perform well. So this, in conjunction with commit reveal, is we've shown mathematically, and we'll release research on this, to really punish those that are not properly running the validation tools. If you're really late to the game on the change in the incentive landscape of a subnet because you're running a weight copying method, this punishes you. And subnet owners have the ability to turn this on, to change the hyperparameters to more or less punish the weight copiers on the subnet. So we think this is a very interesting extension to the protocol. We've known about this solution for a long time. It's just taken a while for us to implement it. And some people have maybe subnets where this doesn't make sense, and we want subnet owners to play with these tools on testnet and evaluate whether or not they can approach weight copying specifically for their subnet through analysis. Like, we can't do everything for you. You have to read our analysis, see these tools in front of you, and make sure you set these parameters properly. Like the same thing as setting the moving average of the registration rate. It's going to take some skill to get this right. But what we've seen is that it can be very positive in terms of pushing out weight copiers. But that's not all. So that's right now. So we're in the middle of this sprint. Well, actually, technically the sprint is over, and so we'll be releasing this to the chain next week on Wednesday. So on mainnet next week, you'll be able to play with Liquid Alpha, and we'll have research that comes along with that and some documentation for subnet owners. We're really excited about people playing with that and making this a thing. But it's not really the major push. I'd say like these last 3 sprints have been growing in impact. And the one that we're really excited about, I think is going to totally change the way in which Bittensor works, is where we're going next. And I think this update is as big as delegated stake itself. We're calling it child hotkeys. And Garrett, if you move to the next slide, the general idea is that right now, validators, like let's say the OTF, TauStats, Guru podcast, and Tau Validator, need to run validators with the same key on every single subnet. And this is really negative for a number of reasons. Well, one, it's a security risk. If you get their key on one subnet, you can use it to attack all other subnets. We're not building a moat, a security moat around each of the subnets and allowing for them to individually fail without causing damage to the larger system. So we built a way for validators that are on the root network, but also just any validator in Bittensor, not just on the root network, to create a child hotkey per subnet and say, hey, well, okay, this is the key that I will use for validation on this subnet, and I'm going to delegate all my weight to that. So this is a huge risk for us right now, is the potential for keys to be lost on individual subnets and costing the entire network. So this is the major reason for child hotkeys. But if we go on to the next slide, we're really excited about the other things it allows people to do. One of them is just access. Subnet owners themselves very rarely have the Tau to be a validator on their own subnets. It means they need to be in constant communication with OTF, TauStats, Guru, Tau Validator, and the other top validators on Bittensor to get them to update the code. They don't get to even run validators to see really if they can get bandwidth on their subnets. Some of them, a lot of subnet owners don't have the bandwidth to even check their own technology. So with child hotkeys, we can make those child hotkeys not even owned by the original validators that are doing the delegation. Validators can delegate to the owner key of a subnet or any other validator on that subnet if they want, and that owner can do the work for that validator and take a take. So we can increase access for subnet owners, but also when it comes to scaling from 37 to 64 to 128 subnets, this will be essential for teams like OTF and TauStats, or any validator really in Bittensor, to delegate the work that is required to some other team on that subnet. You could become a validator on a particular subnet, vying for stake that is being delegated by larger validators in the system, sort of like big fish, small fish. We can allow these teams to focus specifically, isolate themselves about being good validators on individual subnets, and we can delegate to them. But even further, let's go farther. We can use this tool to increase decentralization, because not only do we need to delegate to just one key, that key doesn't even need to be our own, we can delegate to multiple keys, splitting the weight of our validators across different keys, increasing decentralization. So perhaps, as a rule of thumb, someone like Revolt, a Tau validator, will just delegate to every single validator in the top 64. Making it so that if you're a validator that's it's got a couple thousand Tau, you'll still be able to participate in the validation process, in the decentralization of Yuma Consensus on that subnet. So we're really excited about this. It may take more than 2 weeks to get this out, because of mostly it's such a massive change. We want to be in communication with the community about what they think they like or dislike about these changes, and if they want to help us or have suggestions. And yeah, so Sammy says, do we split revenue? Yes, exactly. So just like normal nominated and delegated, normal delegated stake, the validators on these subnets can take a take. They can take a cut for the work that they've done. They can also not. They could even go as far as doing it eventually, and not yet, but they could do a negative take. They could say, hey, delegate your Tau to me on this subnet. I really want it. And be in coordination with the major validators on Bittensor to attract more ownership of this. Final point here. This is essential for something like S-Tau and D-Tau. And this is why we're moving at this cadence, at this speed, to really cut off these major features that will allow us to work well in the larger world of dynamic Tau and stakes Tau. So anyways, I hope that we can, at the end of this call, have people get on stage and talk about this feature, because it's coming down the pipes, as well as Liquid Alpha and Commit Reveal. But I'm also going to hand the mic back to Garrett at this point, and we're going to finish the slides.
Awesome. Yeah, thanks, Jake, for diving into that. So the last thing I'd like to close out for this call is really talk about the path ahead with our roadmap. So we've developed a Q3 roadmap, and what we showed here today is really just a taste of that, like to wrap up Q2. But Q3 is something that we've developed, and we've used community feedback to really get this right, and keep in mind our original goals for this quarter of being stable, being reliable, and being transparent. And so we'll be releasing this to the community in the next couple of weeks, and we'll be really excited to show you guys what we're cooking up. So I just wanted to close with that, and really like outline that this kind of a presentation with transparency is going to be more regular for us, and we're going to be sharing this kind of information with a higher degree of frequency. And when we see this, when we show this roadmap to you, I think it'll be a lot more clear about what's coming down the pipe in the future, and so you can have as much notice as possible for new features and new capabilities, so that you can prepare for that with your subnets and with your miners and validators as well. So yeah, that's really where we want to kind of leave the presentation here. But I think, yeah, we'd like to open up for more conversation and talk about people's questions.
Hell yeah. If anyone wants to come on the stage and just ask their questions here, feel free. You can also just put it into the chat as usual. We'll answer them as we go along. I already answered Sammy's question about split revenue, but if you guys want some more color there, I can provide it. Oh, come on, someone get on stage. I'm just gonna start calling people up. Formalize, you want to add any points here about the technical side of what we're building?
Yeah.
Yeah.
Hi. Yeah. So so as you said, we've had these things lined up. We're working hard to get them to the community, but so technically it's been developed, but as opposed to throwing out new features, we spent the bulk of the time ensuring that things are more resilient. And even though it does seem like sometimes it's we still catch errors, we're improving on that. So time-wise, we plan to focus all our efforts on ensuring that one, we don't get downtime in any of the nets anymore. But two is that this features as they're being built to, like, we pretty much have assembled the best substrate and Rust developers we could find, and we are actively working on them and working on the reliability. But they say it takes a village to raise a child, and Subtensor everyone on this call cares very deeply about Bittensor. So the more we can elicit community engagement, both in working with it, in responding to issues, or most importantly, in calling things that is wrong, are wrong, or suboptimal, I think it helps push the discussion a lot further.
One of the questions here for you, formalized, I think, and more than anyone about this one, was the normalized weights and why that changed consensus and specifically pushed more emission to the root network.
It's pretty complicated. So there was a bug in Yuma that meant that when we store the weight matrices when we store it, we upscale it. We upscale it to max uint 16. But when we actually use that value, we weren't normalizing it. So what it meant is that in certain behaviors, if you set weights all even, and if you set weights all even through the weight setting, when we calculate it, it's not, the proportions weren't correctly reflected. So historically, some people have been getting too much, and some people have been getting too little. So when we eventually normalized it, that was the effect of that. We saw the root networks. We saw some subnets gain about, I think on average, with the exception of root, we found about 20% delta across subnets, with most people going up the root, most people going up 20%, and the other half dropping 20%.
Right. Yeah, it's basically there was a normalization issue when it came to the weights in YC1 on the root network. And so when we fixed that, it changed the whole distribution. Well, mostly for root network, no?
I actually did an analysis, and every subnet lost emission except for the root network.
No. Every subnet did. Are you sure every single subnet lost? Because when we
except for like one or two that were really low.
Yeah, I believe it.
Because
this is the current emissions are effectively what they actually were. In some sense, we were living in a fake universe before, but also I think that now that we fixed this, we can move back.
While we're on this, can I ask why you're max upscaling the weights before you post them to chain?
Max upscaling? Can you explain?
Yeah, with the root weights, before you post them to chain, you max upscale them, which was what caused the bug in the first place. Like if someone validator were to set 20% on 5 different subnets, you would max upscale them, meaning that each 20% actually turned into 64 max, because you would take the max percentage that a validator set on any subnet and then make that U64 max and then normalize the rest based on that value. So then basically those validators were actually setting 500% weight instead of 100% weight. That was the bug. And I think if you just take out the max upscale, you don't have to re-normalize within the root epoch. because now you're normalizing 3 times. You normalize in the do set root weights in Bittensor, and then you max upscale inside the subtensor, and then you re downscale inside the root epoch.
The triple normalization seems like an issue, but we do need to normalize it on chain. I think that's what we changed. Whether or not we normalize it beforehand on Python is really very easy to change. And what matters is if we catch the non-normalized weights on the chain side, because obviously it would allow people to have more weight in the mechanism than they should have. So that's what we've changed. But that's a good point, and something to probably go through and change again on the Python side. If we don't need to do that normalization, we shouldn't.
Can I ask
Jay's
about
question?
Oh.
Mm-hmm. Yeah, no, go for it.
I think if consensus is generally, especially on the subnets where there's little variation, consensus is normally 1 out of 256 for each miner, or 1 out of number of miners, which is like 240 or something. That basically turns the bonds moving average alpha into almost 1, meaning there's not really moving average anymore. Is that the intended purpose?
No, it's not, and we're aware of this. With the actual implementation of liquid alpha, we don't often use the raw consensus value to determine the alpha. What we do is we bound it in some range, and then so let's say that the min is 0.7 and the max is 0.9, so that when we do the normalization, the consensus value will be between those two terms. We're not just using the raw consensus value. So this is not yet in the documentation, but specifically validators will be able to, subnet owners will be able to change this term to increase or decrease the effect of consensus and the scale, the way that it scales from a low value to a high value.
Is the goal in general to speed up the moving average?
The goal is to speed up the moving average for miners that are outside of consensus. So if you're a validator and you're setting weights and you're actually looking at the change in the distribution, oh, this miner went down, this miner turned off, this miner improved their model, and you find that by actually validating the network, then you'll be able to accumulate bonds in that miner faster than simply a weight copier who looks at the current consensus value and sets that as the major as the weights that they pick, which would be a losing strategy. And we've done the analysis here. I perhaps could get Isabel on the screen here, but she's not on the call today. Does that make sense?
Oh, so bonds moving average alpha is now a vector instead of a constant?
Exactly.
Oh, so some bonds matrix values will increase or will change faster than others.
Precisely. So it's a bit hard to draw it on a slide, and we purposely didn't put very much math onto the slides. But if you imagine the bonds matrix as an n by m, where it's validators and miners, right? The alpha term is for a column of that matrix, so it's specific to a miner.
Right.
It's inspecific to a validator. But it changes when a miner reaches consensus. So if all the validators say that this miner is really good, then the speed at which you can accumulate bonds in that miner is slower. Comparatively, if you have a miner that's way out of consensus, nobody's set any weights, and you're a validator and you discover that, oh wow, this guy is actually responding or faster, or training a machine learning model with a lower loss, or storing more files. You discover that through the actual validation process that you would be running as a validator. You'll set weights on that, and you have an advantage because your bonds will accumulate faster. So. Oh, there is actually consensus-based weights. Thank you, Watchmaker. There's a blog here that we've just posted into the chat. You can read about this one. Hoorah! Great. So I think that we paralyzed people with this this update. There's not that many questions from the community. That's maybe a good thing. But then without further ado, I guess we can end the call here at pretty early on, unless there's more questions for people that they want to add. Sammy, do you have any questions? Wow.
Yeah, no questions on child hotkeys, I guess. Okay.
My headers was vector talk. I know I had a hard time with that slide. Because how do you do matrices and vectors in a way that people can understand? I feel like, Garrett, you should throw the images for the slides directly into the Novelty Search chat here, so people can take a look at them.
Yeah, I can do that.
Yeah, that'd be fantastic. Like, as we're going along, we can actually just push them into here.
Can we just share the whole mirror board?
Yeah, we could do that. I mean, but you'd have to lock everything because people can't, or make it so they can't edit. Either way, hey, Mike.
Hi there. Thank you for your work, and thank you for inviting me to the talk. I just had a quick question. If you could share your scripts, how you do the network backups and restores, and do you have any kind of red-blue DevOps automations for any of this, or is it all done by hand? Or was it called red-green deploys? I mean, is there anything that we can do if we're going to try and run our own staging network or a small private network to learn from that you can share?
Garrett, can you answer that question? I am not knowledgeable of this.
So to clarify, you want some scripts to set up your own test environments?
Well, I'm wondering your automation, like, do you have any automations that you use that we can also use so that we're all, singing from the same choir book, basically?
Yeah, let me review with our team and see what we can share. A lot of what we do is very infrastructure specific, especially when it comes to the clones, because we're actually literally copying all of our validator machines bit for bit. And so that's not something that is probably, it's not probably something that is super useful for the community.
But if we build our validators, I mean, let's say I build my validator from scratch and then can clone it through some, a vault to store the wallet and restore it.
Yeah, so let me sync with our team and see what scripts we have that we can share with you, because I think we do have some things that might be helpful for the community as far as testing goes with
that'd be awesome.
setting up DevNets. Yeah,
and then we can also improve that and share them back, because it would be great to have a shared resource. Like, this is the best way, the best practice for backing up. I'm thinking like Terraform for Bittensor. That's what I want.
Yeah, for sure.
So sorry, just to throw something in, like in the spirit of joint community testing, there's a tool we use. I think Fish asked for it a couple of weeks ago. There's a tool we use to clone mainnet and run it locally. So we have it almost ready on a branch, and it's something that we will push to the subtensor, so that for anyone that wants to be able to like make some changes and see how it works locally, that would be your go-to.
Thank you very much. Merci.
Great. David Fields, up on the stage.
Hey, Jake. Yeah, I was curious. So what you're saying is that the performance of the child hotkey will impact the vtrust of the validator. The validator will affect.
vtrust is specific to the hotkey on the subnet. So let's say the main key, the master key, whatever you want to call it, it doesn't have vtrust. Only the keys on a subnet, only the validators on a subnet have vtrust. So the vtrust will not change in the way that it's calculated. Does that make sense? So let's imagine.
I guess
OTF.
I'm sort of thinking more at a higher level, like how, like, can APY for a validator, be affected by their delegation to another, to a child hotkey?
Yes, in a huge way, because that child hotkey APY is will be the APY that the master key attains.
Yeah, gotcha. Yeah, that makes sense.
Yeah, and so there will be some kind of competition. There's likely some competition there on behalf of the master validators about picking performant validators on the individual subnets.
Yeah, that makes sense. I mean, it's a super cool design. I'm excited to kind of dig into it more. I'm curious if you have any like initial thoughts on like some of how that might play out. I mean, it seems like it could also impact kind of subnets with front ends and how they interact with validators. Do you have any like kind of initial thoughts on how some of that dynamic might change?
I think that it can affect, for instance, a subnet owner that attains this child hotkey delegation from a main validator like OTF, are building a front end for their subnet very easily without even needing to get the participation of the main validators. So it could be a very positive way for OTF, for instance, to delegate to owners and have them build products with our stake.
Awesome.
Yeah. I think that this change, the effect of this change can't be understated. It's on par with, I think, the whole concept of nominated stake in the first place, which was just over a year ago. It's hard to imagine, but this is actually, the concept of delegated stake is only just over a year old in Bittensor, and it drastically changed the way that in the landscape of Bittensor.
Well, I've always loved in detail. I think one of the most exciting things there is that it opens up a new landscape for new validators, on subnets. So, this sort of is like a gateway into that.
Yeah, we want more validators. So this is a gateway to it. I think this is a necessary step because in the detail universe as well, with so many subnets, it's just going to be impossible for a validator to be everywhere. Right? Keith does an amazing job, but he's overloaded. I think when it comes to running a lot of these validators, and it opens up the possibility for there to be many more validators, and increase the decentralization of the project in that direction. I think that's going to be a huge win for people.
Yeah, super exciting.
Yeah, no worries, Dave. Great. Okay, so we posted the slides here. Ref is going to take the call over to TGIFT and talk about storage, but this call's not about that, so we'll leave it here. Thanks everyone for coming. This was a short and sweet, but jam-packed one for everyone. Thanks.